As of May 2025, 6 rovers have successfully reached Mars, 5 American, 1 Chinese. We'll explore each one in due course with a special focus on the groundbreaking journeys of spirit and opportunity. Along the way, we'll also delve into the more nuanced narratives of the space race, the relentless pursuit of water on another planet, and humanity's age-old quest to answer the question, are we alone in the universe? Regarding that final question, the answer might be much closer than you think. NASA is now fully dedicated to confirming whether life once existed on the Red Planet, and the cutting-edge Perseverance rover is actively working to provide answers even as we speak. We'll cover Perseverance in detail, but first, we must pay homage to the engineers whose blood, sweat, and tears paved the way, as well as to the pioneering rovers now left behind to weather the harsh Martian elements. The story of Mars exploration, as it turns out, is also the story of heroes, and most of these heroes happen to be robots. The Soviet Union, Mars 2 and 3. When discussing the space race, many people immediately think of the moon landing. However, this tech-driven competition among nations involved far more than just a scramble to the lunar surface. It also featured the lesser-known race to Mars. In fact, it was the Soviets who first touched down on Martian soil and were the pioneers in deploying a rover there. Notably, they reached these milestones years before the United States, even if their successes were only partial. The Soviet Mars program, which ran from 1960 to 1973, was as ambitious as it was chaotic, a trait characteristic of many space race achievements. The program's earliest attempts, which relied on Monier rockets, proved unsuccessful across the board. This struggle began with the Mars 2 MV3 No. 1 in 1962, later known as Sputnik 24. Originally intended to be the first lander to officially touch down on the Martian surface, Sputnik 24 suffered a critical malfunction in its upper stages. Although the lander technically reached orbit, it was stranded and eventually succumbed to natural orbital decay, crashing back to Earth. Undeterred by this setback, the Soviets pressed on with the Mars program. In 1971, the Mars 2 and Mars 3 missions were launched, marking a milestone that was astoundingly ahead of its time. Now, with Sputnik 24 behind us, the Monier rocket was already considered unreliable, but we won't delve into its rush development or later design iterations. What mattered is that between Sputnik 24 and Mars 2 and 3, the Proton K rocket was developed, a massive leap forward in virtually every aspect. Crucially, the Proton K could handle heavier payloads, enabling the Mars 2 and 3 mission packages to come in at 4,650 kilos. These packages included an orbiter, a lander, and the world's first exploration rover. This rover, known as Prop M, was a small, box-shaped 4.5 kilogram autonomous vehicle that remained attached to the lander via a 15-meter umbilical cable. In terms of design, the rover used rotating skis instead of wheels and featured a pair of metal rods for automatic obstacle avoidance. Its onboard scientific equipment was modest, consisting of only a dynamic pentrometer and a radiation densitometer, which allowed for the analysis of soil density and composition. Prop M was programmed to take measurements every 1.5 meters, with these readings observed by television cameras mounted on the lander. Mars 2 was launched first from the Baikonur Cosmodrome in Kazakhstan on May 19, 1971, and the Proton K rocket proved to be a big success. The payload entered orbit on November 27, 1971, and a 4MB orbiter was successfully deployed. It is here, however, that we are introduced to one of the notorious challenges of Mars exploration: dust storms. The American Mariner 9 orbiter, a landmark achievement as the first man-made object to orbit another planet, had arrived 2 weeks before Mars 2. Mariner 9 had already begun broadcasting data, which revealed that Mars was engulfed in the largest storm ever witnessed by humans. The planet's entire atmosphere was enshrouded in dust, with powerful winds sweeping granules and debris up to 7 kilometers above the surface. In a less forgiving twist, the dust storm presented a critical problem. Because the operation was entirely automated, Soviet engineers were only able to receive information and could do nothing to prevent the lander from being sent hurtling into a hellscape. The lander was state-of-the-art at the time. It consisted of a spherical landing capsule 1.2 meters in diameter and a braking shield measuring 2.9 meters. A system combining gas-powered micro-engines, 4 gunpowder engines, and auxiliary parachutes enabled an automatically controlled descent, with altitude, pitch, and yaw managed by internal systems. Upon landing, 4 triangular petals would open to right the lander if it landed at an angle, exposing its scientific equipment to the Martian atmosphere. If touchdown had been successful, the Prop M rover would have been deployed by a robotic arm. The lander plunged into a torrential dust storm, suffered a parachute failure, and was lost. Mars 3, however, achieved a bit more success. Launching 9 days after its twin, Mars 3 carried an almost identical payload to Mars 2, albeit with a different array of scientific instruments. The Mars 3 lander successfully touched down and operated for just 110 seconds before communication was lost. Needless to say, neither rover was actually deployed. Thus, while the Soviets were the first to land on Mars, the accolade for the first rover to touch Martian soil goes to the United States' Sojourner, which we will discuss in a moment. A shifting space exploration mentality. The Mars Pathfinder mission and the Sojourner rover represented the next big leap for Mars exploration, but that milestone wouldn't be reached for another 2 decades. The moon landing had been accomplished, public interest in the space race was dwindling, and soaring NASA expenditures were becoming increasingly difficult to justify. Yet despite limited public attention, the 1970s saw one more remarkable achievement. NASA's Viking Mars exploration program, launched on July 20th, 1976, was an unparalleled success. 2 separate payloads, Viking 1 and Viking 2, launched and achieved their objectives, giving the United States a significant edge in the ongoing Cold War. While the Viking program marked the final flourish of the space race, NASA was determined to celebrate the occasion in grand style. The program was extraordinarily expensive, costing approximately $1.06 billion, and that's in 1970s money. That translates to more than $7 billion in today's currency. One of the primary reasons for the high price tag was NASA's decision to send 2 identical payloads in an effort to ensure success, each comprising a Viking orbiter and a Viking lander. To elaborate further, the Viking orbiters were responsible for capturing images, relaying information between landers and Earth, and recording and transmitting atmospheric data. The Viking 1 orbiter operated for 4 years, completing 1,489 orbits and sent approximately 34,200 images home. The Viking 2 orbiter, while slightly less successful, still managed to stay operational for a year and 11 months, completing 706 orbits and transmitting around 16,000 images. Meanwhile, the Viking landers proved equally successful, each equipped with a state-of-the-art array of scientific instruments focused on the analysis of Martian soil. Viking 1 maintained communication for over 6 years, while Viking 2 did so for around 3. Both landers notably relied on solar power, a factor that will play a central role later in this video. With Mars exploration falling by the wayside in the US after the Viking mission, the stage was set for the Soviets to make a comeback. The 1980s saw them attempt to replicate Viking's success with what became known as the Phobos mission, ambitiously expanding their goals to include the moons of Mars. Like Viking, Phobos carried dual payloads, Phobos 1 and Phobos 2, each equipped with an orbiter and a lander. However, unlike Viking, Phobos 1 lost contact en route to Mars, and Phobos 2 failed to enter the Martian atmosphere. Notably, while the mission was led by the Soviets, it included collaboration from several other countries, including Sweden, Switzerland, Austria, France, West Germany, and even the US. The US's involvement might seem unusual at first, but contrary to popular belief, the Soviets and the US cooperated even during the space race, if only through data sharing. During the Phobos mission, that cooperation broadened when the US agreed to track the twin payloads using NASA's Deep Space Network and openly share the data. Although Phobos was ultimately a failure, it marked a change in the attitudes of space-exploring nations and hinted that the Cold War was finally coming to an end. The tides of change continued into the new decade. In 1992, NASA welcomed a new administrator named Daniel S. Goldin, who wasted no time shaking up the organization on a fundamental level. He declared that the era of spending absurd billions on single missions was over. Instead, Goldin ushered in a new approach centered on the philosophy of faster, better, and cheaper, which proved to be the boost that space exploration really needed. To put it another way, NASA evolved beyond a space race mentality, and that strategic shift proved incredibly successful. In the early 90s, the Discovery program kicked off the missions that brought us Mars Pathfinder and the Sojourner rover. Meanwhile, the Soviets were undergoing significant changes of their own. With the official transition to the Russian Federation in 1991, Russia was keen to prove that it remained a major player on the world stage. To that end, the nation launched Mars 96, basing its designs and technology on those carried over from the Phobos program. While NASA focused on toning down costs and simplifying mission complexity, Russia took a very different approach. Mars 96 became one of the most ambitious space projects in history, built around a 6,180-kilogram payload that included an orbiter, 2 landers, and 2 surface penetration probes. In short, even though the project involved collaboration with France, Germany, and the US, and around 20 other countries, Mars 96 ultimately failed at launch, resulting in a loss of approximately $300 million. In a dramatic twist, the mission's debris spectacularly rained back down to Earth across a 320-kilometer area. The Mars 96 disaster not only marked the first major space exploration effort of the 90s, but also signified Russia's retreat from the Red Planet for over a decade. Mars Pathfinder, the start of a new era. The Mars Pathfinder mission, the second project under NASA's new Discovery umbrella, proved to be a turning point in Martian exploration. The primary aim was to demonstrate the faster, better, cheaper philosophy, and in that regard, it was a resounding success. To put it in perspective, while the Viking missions had cost just over $1 billion, Mars Pathfinder was developed for only $150 million, with an additional $25 million spent on the Sojourner rover, bringing the total expenditure from start to finish to about $280 million. NASA also made a concerted effort to narrow the focus of each mission. The revised goal became to determine whether water existed on Mars, if that water had sustained life in the past, and if any remaining water could support human life. In essence, the strategy was to follow the water. NASA believed that by doing so, they could unravel the secrets of the Red Planet and perhaps even pave the way for its eventual conquest. The Mars Pathfinder payload launched on December 4, 1996 at Cape Canaveral, powered by a Delta II expendable rocket system. The full payload weighed 890 kilos, including the remarkably lightweight 10-kilogram Sojourner rover. The launch went off without a hitch, and the payload arrived in Martian orbit on July 4, 1997. Examining the lander-based station in more detail, its primary purpose was to maintain contact with Earth while also analyzing the Martian soil and atmosphere. 3 main scientific instruments were housed in the lander: the imager for Mars Pathfinder, the specialized stereoscopic camera mounted on an expandable pole, and the atmospheric structure instrument/meteorology package, or animate. Meanwhile, the Sojourner served as the ultimate demonstration of NASA's commitment to cost efficiency. The rover was equipped with only 3 cameras, along with an alpha-proton X-ray spectrometer, allowing it to send images back to Earth and perform basic soil analysis, but not a whole lot more. Its onboard computer, featuring a 2 MHz Intel CPU, 512 kilobytes of RAM, and 186 kilobytes of solid-state storage, was only slightly more capable than a 1983 Nintendo Entertainment System. Regarding landing, NASA refined the process by evolving its earlier method that relied on parachutes and gas rockets. The design carried over elements from Viking, such as the outer aero shield and heat sheet, and still used a supersonic parachute to partially slow the descent. However, once the heat shield was jettisoned and the package came within 355 meters of the surface, a new, multi-layered, interconnected set of airbags was deployed. Thoroughly tested on Earth as early as 1995, these airbags were deemed suitable for a wide range of impact scenarios, whether head-on, grazing, or somewhere in between. As long as the impact speed did not exceed 28 meters per second, the lander and rover were expected to survive. The innovative landing process proved successful, with impact occurring at just 14 meters per second. The airbags absorbed the force of the impact, causing the package to bounce roughly 15 times and reach a peak height of 15 meters before settling. The entire descent, from initial entry into the atmosphere to final landing, lasted no more than 4 minutes. The airbags were then deflated and retracted. After that, not much happened for another 87 minutes. Because the system was solar-powered, NASA simply had to wait for the Martian sun to rise. Fortunately, once solar power was available, the lander opened its petals, the systems engaged, and everything was in working order. So now let's provide some context on how Sojourner operated. If you'd pictured the rover scooting around like a remote-controlled racer, you might be disappointed to learn that the 26-inch long, 19-inch wide, 6-wheeled rover never surpassed a top speed of 1 centimeter per second. It also never strayed more than 12 meters from the Pathfinder lander, remaining strictly within a limited area to ensure reliable communication. With these speeds in mind, considering that the spectrometer required around 10 hours to complete a scan of a single rock, it becomes clear that the job of a NASA engineer involves long periods of observing virtually unchanging camera feeds. It's no wonder then that the engineers came up with creative names for every rock that they could see. For example, the first 3 rocks Sojourner approached were nicknamed Barnacle Bill, Yogi, and Scooby-Doo. Other rocks were given names such as Pooh Bear, Bam Bam Mo, Pop-Tart, Casper, Lamb, and Zaphod. Now, cute little rock names aside, Sojourner made some incredibly valuable discoveries. It determined that Barnacle Bill was almost identical to andesite, the volcanic rock found on Earth. Although this discovery, not exactly surprising, it confirmed that volcanic activity is a feature shared by both Mars and Earth. The analysis of Yogi, a basaltic rock, revealed something rather surprising. Evidence suggested that the rock had likely been deposited by an ancient flood, the very evidence NASA had been seeking. All signs pointed to Mars not only having once harbored water, but also possessing enough of it to trigger significant flooding. Over its operational life, Sojourner traveled 100 meters, transmitted 550 photographs, and conducted chemical analyses at 16 different locations. Meanwhile, the lander sent 2.3 million bits, or 287 megabytes of information, including 16,500 images and 8.5 million measurements of pressure, temperature, and wind. Although the mission was initially planned to last between a week and a month, it far exceeded expectations and continued for a total of 3 months. Communication with the rover eventually failed on October 7, 1997, while the lander remained operational until September 27th. Engineers then attempted to re-establish contact for 5 additional months before ultimately declaring both the lander and rover lost on March 10, 1998. As for what contributed to Sojourner's eventual demise, it's time to introduce the overarching villain of Mars exploration, the Martian winter. Because Mars has an extremely thin atmosphere, about 100 times less dense than Earth's, it has little capacity to hold heat, leading to sudden and dramatic temperature fluctuations. Martian summers, while relatively warm, average around 20 degrees Celsius, with equatorial peaks approaching 35 degrees Celsius. These temperatures create favorable conditions for solar-reliant equipment, a benefit amplified by the fact that Martian seasons are significantly longer than those on Earth, with summer lasting roughly 182 days. The Martian winter, lasting 158 Earth days, is nothing short of a nightmare. Temperatures plunge to lows of minus 123 degrees Celsius, a serious challenge for equipment that can freeze and break. The obvious solution is to keep sensitive hardware heated. Yet even that poses a major challenge. Winter also coincides with the Martian windy season. Although wind speeds generally remain lower than Earth's, dust storms make a semi-regular appearance. A significant Martian dust storm can clog the atmosphere, diminish sunlight, and cover solar panels to the point where they lose functionality. Sojourner's demise came during its first winter, demonstrating that for a rover to endure, serious innovation was required. Although final solutions to these challenges eventually emerged, they did not arrive for over a decade. As a result, the journeys of spirit and opportunity were marked by grim endurance, a healthy dose of luck, and an unexpected surge of media attention. Embarrassing failure follows unprecedented success. So, before Spirit and Opportunity took the world by storm, NASA was celebrating a period of unprecedented confidence. The agency was convinced that the faster, better, and cheaper strategy was finally bearing fruit. Yet little did they know that the worst was yet to come, as the Mars Surveyor 98 mission would soon be widely regarded as one of the most embarrassing failures in the organization's history. The mission comprised the separate launches of the Mars Climate Orbiter on December 11, 1998, and the Mars Polar Lander on January 3, 1999. Both spacecraft were lost without ever completing their missions, and in each case, the circumstances leading to their demise remain highly questionable. Focusing first on the Mars Climate Orbiter, the probe bore many similarities to the previously successful Global Surveyor. The most significant difference was its mission goal to search for signs of water in accordance with NASA's Follow the Water mantra. In particular, NASA intended to detect atmospheric vapor and identify any evidence of ice near the poles. In terms of specifics, the orbiter measured 2.1 meters tall and 1.6 meters wide, and it was constructed using the same graphite aluminium honeycomb supports as the lander. 8 thrusters working in combination with sun sensors and internal measurement units ensured the correct trajectory was maintained, ultimately allowing the orbiter to achieve and sustain orbit. The 638-kilogram payload successfully launched from Cape Canaveral and was scheduled to enter Martian orbit on September 23, 1999. Now, initially, all appeared well. However, things soon took a drastic turn when the orbiter suddenly lost contact. Subsequent investigations revealed that aerospace company Lockheed Martin, responsible for constructing the probe, had used imperial units of measurement while NASA had been using metric. Due to these miscalculations, the orbiter most likely burned up after being sent directly into the Martian atmosphere. With this blunder weighing heavily on morale, NASA shifted its focus to the Mars Polar Lander. The 290-kilogram Mars Polar Lander launched from Cape Canaveral with a mission to land near the South Pole of Mars and finally confirmed the presence of ice. While previous observations with Yogi and possibility that the flood had carried rock deposits were encouraging, definitive proof was still needed. Now, it's important to note that the Mars Polar Lander did not carry a traditional rover. Instead, it deployed a pair of deep-impact probes named Scott and Amundsen after the first explorers to reach Earth's South Pole. These impact probes were fully capable of detecting ice, if only the lander hadn't ultimately failed. The key factor was the base of the lander was specifically built to absorb the impact of a heavy touchdown, employing an aluminium honeycomb deck favored for its impact absorption properties. The problem, however, was that this structure became hypersensitive to vibrations, causing internal sensors to trigger at inappropriate times. After entering the descent phase on December 3, 1999, the lander deployed its legs 40 meters above the surface, and the jolt from the leg deployment mechanism sent vibrations rippling through the structure. Consequently, internal sensors mistakenly concluded that the lander had already touched down, prompting the system to cut the thrusters and leaving the lander to plummet the final 40 meters to the surface. The total cost of the Mars Polar Lander was around $165 million, while the Mars Climate Orbiter came in at approximately $327 million. This represented a significant double failure and unquestionable low point in NASA's history. However, the new, faster, better, and cheaper philosophy eventually proved its worth, and the follow-up missions, just a few years later, fundamentally changed the landscape of space exploration forever. Spirit and Opportunity. Now, if you know anything about Mars exploration, you've likely heard of the Opportunity rover, affectionately known as OPI. Its story captured the world's imagination, resonating with people much like the moon landing did. As a record-breaking explorer on Mars, OPI became a symbol of endurance, perseverance, and the willingness to sacrifice in the name of advancing humanity. It's important to remember that OPI was only half of a pair. Its twin, the Spirit rover, also touched down on Mars just a few weeks apart. Notably, the Mars Exploration Rover did not return to the Martian South Pole, even though confirming the presence of ice there remained a priority. Instead, NASA deferred that investigation until the Phoenix lander's arrival in 2007, while Spirit and Opportunity were tasked with the broader mission of searching for signs of water. Now, Spirit and Opportunity represented a dramatic step up from Sojourner. They were capable of making significantly more precise observations and potentially handling much harsher conditions for longer periods. The twin rovers stood 1.5 meters tall and 2.3 meters wide, 1.6 meters long, weighing in at 180 kilos. Every design effort was made to ensure that they could operate on rough terrain. A standout feature was that each of the rover's 6 wheels was individually powered, ensuring that if one failed, the remaining 5 could keep the mission going. Even with these upgrades, however, top speed was not a priority. Although the maximum speed was increased to 5 centimeters per second, neither rover ever exceeded 2 centimeters per second during their entire mission on Mars. Effort was made to reduce the rover's reliance on orbiters for relaying information back to Earth. As a result, each rover now featured a state-of-the-art, steerable high-gain antenna. In the science department, significant upgrades were also made. The rovers now included improved navigational and viewing cameras, a panoramic camera for broader observations, a specialized lower-resolution monochromatic navigational camera, and 2 black-and-white hazard cameras with a 120-degree field of view. Specialized science tools are housed in each rover's maneuverable robotic arm. These include a miniaturized Moss bar spectrometer paired with an alpha particle X-ray spectrometer, the combination which was designed to investigate the mineralogical content of rocks. The primary tools are complemented by a new rock abrasion tool that can scratch or crack open debris, used in conjunction with an ultra-high-resolution microscopic imager. Regarding the Martian winters, Spirit and Opportunity were outfitted with a significant advantage: dramatically improved batteries coupled with an enhanced solar recharging system. Each rover was equipped with a pair of lithium batteries, each consisting of 8 cells with an 8 amp-hour capacity, paired with substantially larger solar panels. With the panels operating optimally, they generate 900 watt-hours daily, theoretically enabling the rovers not only to function through the night, but potentially survive multiple seasons. However, in the event of a major dust storm, similar to the one that had ended the Soviet Mars 2 and 3 missions, there was little hope that either rover would endure. Consider this a forewarning, much like a giant blinking neon sign proclaiming foreshadowing. Spirit. Spirit launched from Cape Canaveral on June 10, 2003 and touched down on January 4, 2004 using the previously described airbag landing system. The landing proceeded without complications at the Gusev crater, a site chosen based on earlier orbital observations that suggested the presence of water erosion and the possibility that the crater might once have housed a lake. Now, before diving into the timelines for Spirit and Opportunity, it's important to clarify that tracking time on Mars can be a little bit confusing. You see, a day on Mars, known as a sol, lasts about 24 hours and 39 minutes, making it slightly longer than an Earth day. Additionally, as mentioned earlier regarding Mars seasons, a Martian year lasts 687 days, which is nearly twice as long as an Earth year. NASA provides rover timelines in both Earth years and sols, so it can quickly become disorienting. To keep things simple, we'll use Earth months for our timeline, even though Martian seasons don't align with those on Earth. With that being said, Spirit emerged from the lander, captured the first panoramic photos of Gusev crater, and embarked on an incredible journey. The rover took its first tentative steps, a simple 12-meter walk to a nearby site of interest, while capturing an ultra-high-resolution image along the way. Yet against all expectations, it soon appeared that the mission might be over before it truly began. Spirit ceased all communication and responded to commands only intermittently, suggesting a major hardware fault had occurred. Engineers scrambled to diagnose the problem, aware that the rover was at serious risk of depleting its batteries and becoming irretrievably locked in an unrecoverable state. After days of frantic trial and error, it was eventually determined that the rover was caught in a reboot cycle, with the likely culprit being an abundance of files in the flash memory. To avoid what could have been another painfully embarrassing failure, a command was sent on February the 6th to delete the unneeded files. This decisive action rescued the mission from the brink of a very premature failure. Things progressed smoothly from that point, with Spirit comfortably navigating the Mars' southern hemisphere during early winter. On March the 5th, the rover detected the first clear signs of water, a rock identified as magma from earlier volcanic activity. This rock also contained minerals that hinted at liquid water having once been present in the crater, though the evidence wasn't considered conclusive. Meanwhile, around the same time, Opportunity on the opposite side of the planet was making similar discoveries that we'll discuss later. By then, Spirit had already achieved its primary goal, and the mission was deemed a success. However, with all systems still fully operational, NASA shifted its focus to secondary objectives, directing the rover toward nearby points of interest. Spirit spent time maneuvering around various craters and obstacles until it discovered significant deposits of hematite at the base of Columbia Hills, a discovery that we will return to later. The Martian winter was now arriving in earnest, and Spirit was about to face its harshest conditions yet. Major temperature dips and the accumulation of dust on its solar panels became daily challenges. In response, NASA implemented a deep sleep cycle, meaning the rover powered down at night while its heaters kept it alive, only to resume operations each morning. In NASA's view, this marked the beginning of the end. Still, though, the journey continued. Spirit pressed on toward additional signs of interest, gathering more valuable information along the way. As months passed, winter fully settled in, and every effort was made to conserve energy. Remarkably, the rover endured the Martian winter, exceeding expectations even though its daily energy generation fluctuated and overall functionality was impacted. Then, as winter began to wane, the first of many unexpected events helped bring the rover back from the brink. Inexplicably, Spirit's solar efficiency jumped from a dramatically reduced 60% to 94% almost overnight. Engineers were baffled by the sudden improvement, but a day later they captured footage of Martian dust devils. In a truly serendipitous turn of events, one of these dust devils had swept clean the solar panels, effectively renewing Spirit's strength and extending a mission that had been on its last legs for several months. Spirit pressed on with renewed vigor, traveling a total of 4,971 meters by August 2005. Along the way, the rover reached the top of Husband Hill, a milestone that had been considered only a secondary objective, and even managed to observe the Martian moons Phobos and Deimos. Then came 2006, and the first sign of what would ultimately prove to be Spirit's downfall. On March the 13th, after traveling more than 7 kilometers, the rover's front wheel ceased functioning. NASA engineers, who had been preparing for another harsh Martian winter, were suddenly compelled to drive Spirit in reverse. At that point, the solar efficiency had again begun to gradually decline, and with its troublesome wheel hampering progress, Spirit was largely confined to a ridge. Yet defying all odds, the rover survived a second winter and continued to operate despite its crippled wheel. Following this came another serendipitous occurrence. With the broken wheel carving a trough in the soil behind the rover, a NASA engineer noticed something intriguing just below the top layer: silica. Now on Earth, this mineral typically appears in areas where volcanic activity produces steam and supports abundant bacterial life. If similar conditions had generated silica on Mars, it would not only point to the presence of water, but also serve as strong evidence that microbial life had flourished. Spirit continued its journey, exploring an area known as the Home Plate Plateau until June 2007. Up to that point, Spirit had been incredibly lucky. However, that streak of fortune finally came to an end when a planet-wide dust storm began to brew, suddenly reducing its chances of survival to nearly nothing. Engineers had no choice but to place Spirit into deep hibernation and hope for the best, with NASA releasing an ominous statement in response. To quote it, "We're rooting for our rovers to survive these storms, but they were never designed for conditions this intense." End quote. At this point, it's important to understand how the rover's solar recharging systems worked. Estimates suggested that during the summer, about 900 watt-hours per day could be generated. However, at least 150 watt-hours per day were required to keep the internal heaters running. Any output below 150 meant that the heaters would eventually fail during the night, and as a result, the rovers would automatically enter hibernation and most likely freeze. During the worst of the June 2007 dust storm, Spirit's energy generation briefly dropped to 128 watt-hours. It was only a matter of time before the batteries would run dry and the heaters would fail. Yet, defying the odds, the rover managed to hang on until August. As the storm began to show signs of clearing, engineers seized the opportunity and moved Spirit to an incline on Home Plate Plateau that offered the best possible exposure to sunlight. Spirit once again managed to survive, but only barely. The solar panels were almost entirely covered in dust, with energy production hovering at 235 watt-hours per day. This was enough only to keep essential systems alive, so all non-critical instruments were turned off. With hopes already waning, the situation worsened when a second dust storm hit in November 2008. Solar generation plummeted to 89 watt-hours per day, reaching critically low levels. Engineers were forced to shut down systems completely, including the heaters. As this decision was made on November the 10th, it was considered the unofficial end of Spirit. Incredibly defying all odds once again, the rover awoke on November the 13th and managed to send a communication signal. After the storm passed, by November the 14th, power generation had increased to 169 watt-hours per day. Even more remarkable was that Spirit systems and scientific instruments had avoided damage despite enduring several consecutive nights of nightmarishly cold conditions. The rover remained stationary as it attempted to recharge its batteries. Then, on February the 6th, 2009, another miracle occurred. Favorable winds blew dust off the solar panels and energy generation increased to 372 watts by April 29th. Unfortunately, the resurrection was short-lived. Engineers decided to move the rover from its stationary position, but in doing so, Spirit was unintentionally guided into a sand trap. On May the 1st, the rover hit a cache of powder-fine iron sulfate hidden beneath a layer of dust, and its wheels were unable to gain traction, leaving Spirit stuck. For months, engineers worked to maneuver the rover free, but fate was sealed in November when a second wheel failed. By January 2010, another winter was setting in, and the decision was made to disable the wheels permanently, redefining Spirit as a stationary observation platform. However, with the rover stuck on an unfavorable incline and receiving insufficient sunlight to power its solar panels, systems were shut down, once again, on March 22nd. Spirit managed one last communication, but then went silent on March the 30th, marking the end of its journey. Engineers held on hope, praying that an unexpected cleaning event might save the day. Yet, despite continued efforts to re-establish communication into 2011, Spirit was declared officially lost on May 25th, 2011. Originally, the mission was planned to last only 90 sols, yet Spirit endured for 6 Earth years and 77 days. In effect, this means Spirit outlasted expectations by over 20 times and covered 7.72 kilometers, far exceeding its planned 600 meters. As remarkable as all of this is, it pales in comparison to the extraordinary journey of Oppie. Opportunity. Launched on July the 8th, 2003, just a little under a month after Spirit, Opportunity, or Oppie, then referred to as She, following nautical tradition, touched down on Mars on January the 25th, 2004. She landed in Eagle Crater, located in the northern hemisphere on the opposite side of the planet, and like her twin, was tasked with searching for telltale signs of water. The beginning of Oppie's journey hinted at what was to come. With Martian summer on the horizon and the lander unintentionally touching down right in an impact crater, the landing was fortuitously dubbed a hole-in-one. The crater was named Eagle as a playful nod to golf terminology. Unlike Spirit, which experienced early system problems, Oppie got off to a strong start, sending NASA a wealth of early images of Eagle Crater's interior. These observations quickly revealed that the crater had once been a lake, its sedimentary layers marking the ancient waterlines. By February the 10th, further investigation pushed the needle toward water. Thin layers of bedrock indicated that a water current had once been present, suggesting that the area may have even hosted a river. In the months that followed, Oppie gathered additional evidence, including hematite-rich fragments, and this is when things got really interesting. As you may recall from Spirit's mission, hematite, commonly known as blueberries because of its shape, is a strong indicator of past water. Now on Earth, you might call this mineral rust or iron oxide, which forms when iron is exposed to oxygen and water. The hematite on Mars likely formed in or near ancient lakes, although its origins were not known with 100% certainty. Oppie spent half of her originally designated life in Eagle Crater before being directed to investigate the nearby Endurance Crater and then the impact site of her own heat shield from January 2005. Here, Oppie encountered a baseball-sized meteorite. Although meteorite shards are regularly discovered on the Red Planet, this one was remarkable for remaining intact. Analysis by Oppie's onboard science instruments confirms that, unsurprisingly, the meteorite was identical to those found on Earth, consisting of 93% iron and 7% nickel. Following this discovery, Oppie was directed to the distant Victoria crater, a point of interest previously observed by an orbiter. Along the way, she made stops at both Argo and Vostok craters, set a record for distance traveled during a single sol on March the 20th, and on April the 26th successfully avoided the fate of Spirit by escaping a minor sand trap. The first crisis arrived on November the 3rd, 2005, in the form of a localized dust storm. It hit at the worst possible time, during a sleep period introduced after early signs of dust accumulation on the solar panels. As power efficiency dropped, the decision was made to halt any scientific investigations. Yet, as with Spirit, chance intervened. A favorable wind swept the dust from the solar panels, boosting solar efficiency to 720 watt-hours, and Oppie soldiered on. Even as this good fortune was celebrated, the second crisis emerged in December 2005. Oppie's robotic arm began stalling, and an investigation revealed that its heater was stuck in the on position. An automatic safety system was regularly shutting the heater off to prevent damage. Unfortunately, as the Martian summer ended and the first winter approached, a constantly active heater during the winter days would have drained the batteries, leaving nothing to power the rover through the freezing nights. With no other options, engineers decided to simply cut power to the heater at night, a compromise that bought a few more months. It was almost inevitable that the arm would eventually fail outright, but the pressing concern was surviving the winter. Despite the worsening situation, Oppie pressed on toward Victoria Crater, continuing its journey into 2006 and arriving in September of that year. Victoria Crater had attracted major interest due to its immense size, nearly a kilometer across and plunging 75 meters into the surface. Now, if you recall Spirit's timeline, it was around this time that NASA made the ominous announcement, "We're rooting for our rovers to survive these storms." So on January the 4th, 2007, the same storm that had struck Spirit was about to hit Oppie. Energy production fell sharply to 280, leading to hibernation, and by July it was dipping below the critical 150 benchmark. As July ended, a NASA representative issued a statement. There is a real risk that Opportunity will trip a low-power fault. When this fault is triggered, the rover systems disconnect the batteries, putting Opportunity to sleep. Each sol, the system checks whether there is sufficient available power to wake up and perform the daily fault communications. If there isn't enough energy, Opportunity remains asleep, potentially for days, weeks, or even months, depending on the weather conditions. Now, most were already saying goodbye to Oppie, but like Spirit, the rover defied incredible odds and awoke. By August, conditions were improving, and by the 27th, the batteries had charged enough to resume the mission. At last, the rover could enter Victoria Crater, albeit with a now almost entirely useless robotic arm. At this point, however, NASA engineers truly outdid themselves. They attempted to unstow the arm, but the motor stalled immediately. Joint 1, which had now endured several additional months of temperature fluctuations, was nearly completely locked up. To work around this issue, engineers waited until early morning when the joint heater was switched on for the day. They timed it just before overheating could occur, and the safety systems would shut the heater down. During this brief period, Joint 1 was at its most malleable, so an attempt was made to deploy the arm under these conditions. And the plan succeeded, but with the downside that the arm could never be stowed again, remaining a handicap for the rest of the journey. Oppie then investigated Victoria Crater, and with expectations already far exceeded, the decision was made to send her to Endeavour, about 12 kilometers away. Endeavour is a massive crater, 22 kilometers wide, 500 meters deep, and was deemed another top investigation priority. So Oppie set off to visit the crater, with the journey taking up the next 2 years of her life. Now, we won't delve into details for those 2 years because most of the time was simply spent traveling. The only events worth noting are the discoveries of additional meteorites, one named Block Island on July the 28th, another named Shelter Island, and a third, Mackinac Island, on October the 17th. The halfway point of the journey was passed on September the 10th, 2010, and by late March 2011, the rover had reached the 30-kilometer milestone, 50 times more than originally planned. By August 29th, the rover had operated for a period of 30 times longer than its initial 30-day mission. Endeavour Crater was reached on August the 9th, 2011, a point in Oppie's journey referred to as Spirit Point. If you recall, on the other side of the planet, Oppie's twin was officially declared gone for good. For Oppie, however, it marked a new beginning. The period following Spirit Point is called a second life because, remarkably, it unfolded with virtually no major incidents. It was first and foremost decided that the rover would drive around the rim of the 22-kilometer-wide Endeavour Crater, a mission that came to define the second life of this extraordinary machine. A major discovery arrived surprisingly quickly in December 2011 when Oppie finally achieved what was commonly referred to as the slam dunk. The presence of water on Mars had already been almost conclusively confirmed, but the detection of gypsum crystals ended any remaining doubts. Since gypsum forms only in the presence of water, it definitively proved that the area had once hosted a lake. With this major discovery behind her, Oppie, now clearly showing her age, prepared for another winter as she entered 2012. Determined to complete a journey around the entire circumference of Endeavour, she eventually had to park at Greeley Haven to brave more freezing weather. On July 2, 2012, a small celebration was held to mark the rover's survival for 3,000 Martian days. Incidentally, this milestone occurred as the Curiosity rover was landing elsewhere on the planet, a topic that we're going to explore shortly. The winter passed, and on May 16th, it was confirmed that Oppie had officially travelled farther than any other vehicle on another planet, outperforming the Apollo 17 lunar rover. On January 23rd, 2014, the official 10th anniversary of Oppie's landing on Mars came and went, marked by a self-portrait celebration. The journey around Endeavour continued, but with NASA taking a new angle. A NASA representative declared that the mission was now officially focusing on searching for signs of past microbial life, launching this new phase immediately with opportunity and curiosity. Almost as if she understood that she had officially gone above and beyond the call of duty, the first signs of her end began to appear. Oppie developed memory problems in late 2014, and although the issue was temporarily addressed by a reformat, the problems persisted until her final days. But Oppie still had life in her, and continued circumnavigating Endeavour while investigating an area called the Marathon Valley. In March 2015, the memory problems returned, and analysis revealed that Memory Bank 7 was corrupted and had to be bypassed. She endured yet another winter, but by November, the memory issues had deteriorated to the point of being called amnesia. The systems no longer recorded mission data, leading to a decision to disable the SSD entirely and switch to a RAM-only mode. Although Oppie was still able to function, she no longer remembered or recorded events. Incredibly, still clinging to life, Oppie conducted further investigations in Marathon Valley, exited the other side in September 2016, and completed her journey around Endeavour in May 2017. The valley where she arrived was named Perseverance in her honor, and true to that accolade, she continued for a few more months. She then began investigating the new valley, celebrating surviving 5,000 souls in February 2018, and finally, a dust storm rolled in June 2018. Plans were hastily assembled to survive the storm. It was decided that Oppie would sleep through the event, waking only in the afternoons to take measurements and send images. However, this plan was abandoned almost immediately as power generation plunged to the lowest levels ever recorded. On June 10, 2018, Oppie made her final communication. Technically, the message was just a systems report. In essence, it translated to, "My battery is low and it's getting dark." Repeated efforts were made to re-establish contact, but by November 27th, it became clear that Oppie had found her final resting place. An additional 1,000 recovery attempts were later made, and on February 13th, 2019, she was declared lost for good. At a press conference, NASA Associate Administrator Thomas Zurbuchen stated, "It is therefore that I am standing here with a deep sense of appreciation and gratitude that I declare the Opportunity mission is complete." It was revealed in a genuinely touching moment that the last data transmitted to Oppie was the song "I'll Be Seeing You" by Billie Holiday. By the time its mission ended, the rover had been operational for an astounding 5,498 sols or 14 Earth years and 15 days. It's almost difficult to comprehend that Oppie launched during the first term of George W. Bush and was officially lost during the first Trump administration. The official discovery of ice on Mars also took place during Opportunity's lifetime. While the rover was deeply cherished, it's easy to overlook that a major milestone occurred when ice was detected on the Red Planet. A separate mission under the Mars exploration program known as Phoenix launched early in Oppie's life on August 4, 2007. Phoenix was officially the most expensive mission since NASA shifted to the cheaper, better, and faster philosophy, costing $420 million. With confidence at an all-time high following previous setbacks, the mission was conceived as a bold effort to make up for the embarrassment of the Mars Polar Lander disaster. After a routine launch, Phoenix entered the Martian atmosphere on May 25, 2008. Notably, the Mars Reconnaissance Orbiter captured an image of the lander suspended by its parachute, with the landing site located in the green valley of Vastitas Borealis. The first images arrived, and as expected, revealed that the landing area was flat, strewn with pebbles, and marked by distinctive troughs that separated polygonal surface patterns approximately 5 meters wide. These patterns suggested that ice likely exists beneath the surface, resembling formations found in the Earth's Arctic, where a layer of soil over permafrost continually thaws and refreezes. The robotic arm was deployed on May 28th and made its first contact with the Martian soil on May 31st, 2008. A brief period of confusion followed when difficulties arose in inserting the initial sample into the thermal and devolved gas analyzer. When the sample was finally analyzed on June 11th, no signs of water were detected. Although the initial result was concerning, subsequent analyses indicated that the water had simply evaporated during the delay. After this brief diversion, later in the same month, the trench dug by the arm was photographed and clumps of bright material were observed. Over the following days, these clumps vaporized, strongly suggesting the presence of ice. By July 31st, NASA was comfortable declaring once and for all that ice was present, especially as additional samples were heated to 0 degrees Celsius and water vapor was clearly detected. The ultimate goal of Phoenix had been a resounding success. In a best-case scenario, it was hoped that the lander would last into the Martian winter, allowing scientists to witness firsthand the development of ice sheets across the poles. It was believed that a carbon dioxide ice sheet, at least a meter thick, would form, with Phoenix broadcasting images of the process back to Earth. As winter approached, the heaters that kept the equipment operational were shut down, and all available energy was redirected to system survival. Sadly, Phoenix did not survive the winter, with its last communication occurring on November the 10th. Attempts to re-establish contact with the lander failed in January 2010, and project manager Barry Goldstein declared it dead on May 24, 2010. Later, the Mars Reconnaissance Orbiter observed Phoenix covered in a layer of ice estimated to be around 19 centimeters thick. Curiosity. And at last, we arrive at one of the two rovers that's still functional today, Curiosity. Now, as you may recall, Curiosity landed on Mars around the time when Opportunity was celebrating 3,000 Martian days. Despite the overlapping timelines, Curiosity represents a massive step forward in every department, ushering in the modern era of Mars exploration. Weighing 900 kilograms and measuring 2.2 meters in height and 2.9 meters in length, Curiosity boasts a top speed of 4 centimeters per second. It's equipped with an extensive array of scientific instruments and a radioisotope thermoelectric generator, commonly known as a nuclear power source. This generator produces roughly 9 megajoules of electrical power daily through the decay of plutonium-238, ensuring that the availability of the Martian sun is no longer a concern. Even more impressive is that while Curiosity does have strategically placed heaters on key components, the excess heat produced by its generator is circulated throughout the rover via 60 meters of internal tubing. This design keeps the systems warm at no additional power cost, putting Curiosity light years ahead of the Spirit and Opportunity rovers. The generator has a minimum life expectancy of 14 years, suggesting that the rover should still have several years of operation as of May 2025. In terms of cost, these improvements certainly did not come cheap. Curiosity is among the most expensive projects ever undertaken by NASA, with its cost in today's dollars reaching a staggering $3.2 billion. Curiosity officially launched on November 26, 2011, entered Mars's atmosphere and touched down on August 5, 2012. By that time, the cultural impact of NASA missions had taken on a whole new dimension. Spirit and Opportunity had attracted major media attention, the most since the original moon landing, and although Curiosity's landing went off without a hitch, the surrounding media frenzy was extensive. The landing was broadcast live on NASA TV and generated such high demand that servers crashed. Meanwhile, in Times Square, the event was displayed on a giant screen, drawing in an estimated 1,000 people and bringing foot traffic to a standstill. With all eyes on the mission, NASA breathed a sigh of relief when Curiosity touched down in the enormous 154-kilometer diameter Gale crater and was deployed on August 6, 2012. Since then, Curiosity has dedicated its entire mission to investigating the interior of the Gale crater and has made several notable discoveries. The mission nearly ended prematurely in its first months when the rover suffered a major computer hardware failure in February 2013. A memory corruption problem, similar to the one experienced by OPI, caused the system to refuse to enter its sleep cycle. The issue was resolved on February the 28th by shutting down the primary computer and allowing the co-pilot system to take over. To this day, the rover functions entirely on its backup system, although all systems remain fully operational. Following this early crisis in December 2012, Curiosity's original 2-year mission was extended indefinitely, reflecting NASA's expectation that the rover's operational life could match or even exceed that of OPI. In terms of discoveries, chemical and mineral evidence confirmed once again that Gale Crater had once hosted a lake. Later, the rover found the largest organic molecules ever discovered on Mars after cracking open mudstone with fragments believed to be fatty acids. These fatty acids are a sign that prebiotic processing once took place on the planet, strongly suggesting that microbial life may have once flourished. Curiosity has traveled 34.77 kilometers and is currently exploring the Geddes Vallis Channel on Mount Sharp. The rover has been operational for 12 years and about 270 days, making it the second largest surviving rover in NASA's history after Opportunity. Schiaparelli. While Perseverance is the next big step in advancing our exploration efforts, it's important to acknowledge the European Schiaparelli and the InSight Mars lander. Starting with Schiaparelli, the lander was developed as part of the ExoMars program under the umbrella of the larger Aurora program. The project was a collaboration between the European Space Agency and Roscosmos, the Russian space agency. This marked Russia's most ambitious Mars endeavor since the failed Phobos Grunt mission in 2011, which had targeted Phobos, one of Mars's moons. The Schiaparelli package, which included both a lander and an orbiter, was built in Italy and designed primarily to test technology for future landings. The mission ended in a disappointing failure as contact was lost on October the 19th, about a minute before the final landing phase. Originally, the Schiaparelli mission was planned to include a rover. However, a clearly wise risk assessment determined that it was safer to send a test lander first. Much of our discussion today has focused on NASA because the United States has clearly been leading in terms of success. However, the ESA remains highly active, concentrating on collaborations with other agencies, most recently with NASA and the Chinese National Space Administration. The ESA is currently developing a follow-up exo-rover mission featuring a rover still under development referred to as Rosalind Franklin. The mission was originally slated for launch in 2022, but following the Russian invasion of Ukraine and Roscosmos backing out, the ESA is now collaborating with NASA. Additionally, the ESA is actively developing an Earth return orbiter, an essential component of the unfolding Mars initiative, which we will discuss in just a moment. Perseverance. The 2012 Curiosity landing marked a high-profile success for NASA, capturing unprecedented public attention, pioneering cutting-edge technology, and advancing established goals. Yet an unexpected factor, namely the United States' recession, thrust the entire organization into uncertainty. Budgets were slashed across the board, leading to the cancellation of a planned 2020 return to the Moon. Then in 2011, a report from the National Academies of Sciences, Engineering, and Medicine set NASA on an entirely new course. In short, the report recommended that NASA redirect its focus and channel all future efforts into the most ambitious, multi-phase plan humanity has ever attempted. As part of this effort, NASA would collaborate with the European Space Agency, or ESA, and together the nations would undertake a Mars sample return, a mission that's currently underway as you watch this very video. The new objective began with the $2.5 billion Perseverance rover, which isn't very different from Curiosity. It even uses the same radioisotope thermoelectric generator. The key difference is that while Curiosity continues with exploratory missions, Perseverance is primarily tasked with collecting physical samples that will eventually be returned to Earth. At least the samples are expected to reach Earth, provided that the later, far more ambitious steps succeed. Perseverance is equipped with a drill, among other scientific tools, that can extract a core from an intriguing rock, insert that core into a titanium tube, and then safely store the sample. The plan is for the sample retrieval lander to collect these tubes, transfer them to a Mars ascent vehicle, and ultimately send them on a return journey to Earth. Apart from the sample collection equipment, there is one other specialized tool worthy of mention, a tool that doesn't always receive the attention it deserves. Ingenuity, affectionately known as Ginny, was a 1.8 kilogram solar-powered drone sent with Perseverance to demonstrate that flight was possible in Mars's thin atmosphere. Ginny was a resounding success, completing 5 initial test flights before adding an extra 72 bonus flights. Equipped with a pair of cameras, the drone was used to scout interesting locations, typically flying no more than 3 to 5 meters above the surface for roughly 90 seconds at a time. Although Ginny proved far more robust than anticipated, it ultimately broke rotor blades on its final flight on January 18, 2024. Turning our focus to the rover itself, Perseverance launched on July 30, 2020, landed on Mars on February 18, 2021, and has since traveled 33.43 kilometers. The rover has spent its time exploring Jezero Crater, its landing site, once again uncovering evidence of a former lake, while also collecting 27 sealed samples for eventual return to Earth, as well as several rock cores. One fascinating discovery is the so-called leopard spots on a rock, which might indicate ancient chemical reactions. Although no definitive conclusions have been reached and the spots must be studied on Earth before we can be certain, this finding could be the first evidence of life on another planet. A sample return mission is scheduled to take place in 2033. Moving on to the latest orbiter and rover, Taiwan-1 and Zhurong. Launched on July 23, 2020 aboard China's heavy-lift rocket Long March 5, also known as Changzheng 5, the combined mission proceeded flawlessly. The spacecraft landed on Mars on May 14, 2021, making China the third nation to achieve a successful landing on the Red Planet. Unlike the more advanced Perseverance and Curiosity rovers, Zhurong was designed solely for exploration. It carried instruments such as ground-penetrating radar, a magnetometer, and topographic cameras, all of which were geared more toward careful observation than physical analysis. Despite its focused mission scope, Zhurong enjoyed a long and successful operational period, even collaborating with the European Space Agency for communications. Over the course of its mission, Zhurong gathered additional evidence of Mars's watery past, including indications that snow and frost form on the Martian dunes, as well as new data from an area known as Utopia Planitia. This region is speculated to have once served as a coastline, with strong signs suggesting that Mars may have harbored an ocean at some point in its history. Relying on solar power, Zhurong was placed into hibernation mode in May 2022 in anticipation of the harsh Martian winter, with plans to endure the cold and resume communication on December 26th. Utopia Planitia, in particular, is an extremely frigid area where temperatures can plummet to around -100 degrees Celsius during the winter months. The rover had been programmed to exit hibernation when its power levels reached 140 watts, but communication was not re-established as expected. The likely cause of this issue included an accumulation of dust and the bone-chillingly cold temperatures that prevailed, preventing the rover from successfully reawakening. By April 25, 2023, mission designer Zhang Rongqiao announced that Zhu Rong was gone for good, accompanied by a follow-up report summarizing the evidence gathered. The report suggested that approximately 400,000 years ago, the planet may have undergone a massive climate change event, and that prior to this, conditions on the planet were not too dissimilar to those from Earth. It concluded, echoing speculation put forth by NASA, that the planet had once boasted an ocean covering roughly a third of its surface. Future plans. Now, it's safe to say that the future of Mars exploration has never been more ambitious, beginning with the multi-phase mission to collect samples and return them to Earth. According to current projections, a sample retrieval lander with its own rover will touch down in 2028. Once deployed, the rover will collect the titanium sample tubes and deliver them to a Mars ascent vehicle, which is currently under development at Lockheed Martin Space and Northrop Grumman. The plan is for the ascent vehicle to rendezvous with the Earth return orbiter being developed at the European Space Agency, which will transport the samples back to Earth for further study. If everything goes according to plan, the samples should arrive on Earth by 2033, though there is still much work required to successfully develop, construct, and test all of the components of the mission. Beyond this, the plans remain somewhat vague, though you've likely heard that NASA is working toward a manned Mars mission projected to occur sometime in the 2030s. However, if you listen to NASA's billionaire ally SpaceX, the target date could be as early as 2029. Either way, while the specifics of what humans will do upon landing on Mars remains unclear, there's plenty of talk about exploration, discovery, and establishing a permanent human colony. Additionally, a key motivation appears to be the potential mining of valuable Martian minerals, including iron-rich hematite and magnetite. Regardless of the details of what we do once we arrive, it seems certain that humans will soon walk on Mars, and that is undoubtedly an achievement worth celebrating. Thank you for watching.